So we designed a power plant around that same principle. And we've been pushing it now for a couple of years. We had some, it takes a lot considering we don't have a lobby. You know, there's a solar lobby, there's a wind lobby, there's a geothermal lobby. So we're a small company and we're trying to enter the market. And most of the solicitations from the DOE are specific to solar, specific to wind, specific to geothermal. Same with the states. So our choice at this point is, one, we go with a large company, sell 75% of our company, and then they'll assist us, which is what we've been offered numerous times. And the other is to just continue to wait. As a small company, I don't have access to $20 or $30 million. I couldn't finance $20 or $30 million. So we're stuck in a limbo that comes with a lot of development. You know, like I said, there's a lot of development within the states and within the federal government that really is just stonewalled around. Like I said, when you read the DOE solicitations, they are written specifically for the accepted forms. So we've been pushing off of that, like I said, about 2.5 years now. For the state of California, we answered an RFP for a 3 megawatt site in Ramona. Went to the CEC, this is the California Energy Commission. The California Energy Commission basically had to do what's called pre-certification. We want to become an RPS certified power farm. That's the plan. So we go to the CEC and we go, here's our plan. No problem with the engineering, but we're not listed in the state legislature in the language. So if we have a solar set up or a battery set up or one of these other, we could instantly go through and they would pre-certify us. This is not for certification, this is pre-certification to basically be allowed to build your plant so they can measure the greenhouse gases. SDG&E is the one paying for the plant, who wants the plant. We want to build the plant. The state of California has basically said no, go away. So we're open to solar, wind, geothermal, etc. So we're in that little thing. They said there's a 10 to 15 year curve on new technologies. So we're at this, if you go all the way back to the reverse condenser, 5 years. If you go to the induction energy fuel plant, you're talking 2.5 years. I don't know, you know, as a small business, spend another 10 years or 8 years doing this is really almost not an option. So this is all, for the most part, privately financed. This comes out of the partners in the company who pay for everything. So we purchased a power plant over in Massachusetts. We're going to be converting. We do still have to deal with solicitations around. But the time level when it's something that actually can make a big difference, because we're not intermittent. Solar shuts off at 6 o'clock at night. Doesn't matter what you do. Solar is an intermittent form. So from 6 to 8 in the morning, you're producing zero power. We can go through that. We have a 95% capacity factor. We can run 24 hours a day. So we're an ideal source, but we just can't seem to get traction. So,
can you talk a little bit about, just so the audience can get an appreciation that if you could cross this chasm and get adoption, you know, you and I have talked about quite a bit about really all the amazing opportunities that this could create in decommissioned nuclear plants, decommissioned coal facilities, desalination. Can you kind of run through where you see the benefits at?
Yeah, our first purchase, when I talked about the Ware plant, is a former coal plant. It's a biofuels plant. We basically built this steam generator right up there. And you look on the insides of that, these are the induction coils that are going around. So this creates the energy field in the inside of there. Anything within that energy bubble will acquire the temperatures we want, and it is the most selective heating you can have. So as the flow comes in and comes through, it's within those tubes. We're going to do about 1,500 degrees. This is a majorly tunable boiler. There's no boiler that's ever been built like this. I have complete control of this from 10 degrees to, well, we're using 444 or austenitic in this, which is a type of stainless steel. We have complete temperature control from 75 degrees to 1,500 degrees. Our only limitation is our stainless, which you can buy higher trees. The 444 hits about 1,600 degrees. That's its working maximum temperature. So as we put this, with this tunability, typically when you build power plants or thermal plants, you build your boiler for your steam turbine generator. What we've done is we built a steam turbine generator that we can run on almost any boiler. So we'll go into this 1968 former coal plant, and we'll build one of these. And we'll use an induction power supply. We're partnered with a company called Inductotherm. They developed this system with us. They're the largest induction company in the world. They have 90 subsidiaries. They'll come in, we'll use their power supplies. Their power supplies are kind of what our kicker. They run a VIP supply, which is it's the Ferrari of induction power supplies. So we'll be able to take this and we'll put this in that ware plant. One, you'll reclaim what is a brown site. This is a brown field. This is other businesses cannot go into this. But you see a lot in the modern world. You see the power companies put little tiny solar fields on these sites. Well, the fact of the matter is, as soon as those sites stop making power for a living and you have to rezone it, they require tens of millions of dollars of remediation. Even if ware stops producing power, you're talking about tens of millions of dollars, asbestos, all manner of carcinogens, coal sediment tanks. We can go into those plants anywhere in the country. The IER report had, I think, 115 coal plants shut down last year, which is thousands and thousands of megawatts of power. Over the last 10 years, there's been close to 1,000 plants. So those assets are out there. When those assets are not just the plants, and not just the steam turbine generator, the distribution, the interconnection to the substations and to your houses, those are all still in place. Those are tens to hundreds of millions of dollars. I was just in Manhattan when we were pitching Con Ed. Con Ed has I think a 35 megawatt deficit in the summer. That means the summer, they peak out 35 megawatts over the base. So to get that 35 megawatts to build a substation in Manhattan is close to $1.5 billion for one substation. This is compact. Like I said, it comes back off the big inspiration of this is the nuclear side of the Navy. Very compact steam generators, very compact reactors. We've taken the reactor that the size, so we can spread our equipment out. We can spread it in existing plants without disturbing existing boilers, which disturbs asbestos, disturbs all kinds of pollutants. So the idea is to convert as many of those assets as we can after we get in there. But once again, you get to the stopping block. You know, we purchased Ware, Massachusetts. It's an old, decrepit, 75-foot tall stack Massachusetts plant sitting on a big river going down it. It's beautiful, but it's a filthy old brownfield. We can go in there and reclaim that. And we have some secondary stuff that comes with this, because heat is, the ability to generate heat cheaply is the key to everything. It's key to every industry. When you talk refining, if you're in a refinery process, well, the ingredients to refinery are hydrogen, steam, and heat. Well, we're running this bad boy. We can run as much steam as we want on top of it. We can run the heat for the process. So when you look at a typical barrel of oil, if I would say close to, if it's $22 production cost, $8 to $12 of that is directly heat. That's what it is. So every process is like this. We've designed this as well for fitting onto existing ships. You have diesel electric ships where we can come in, run smaller versions of this boiler, and run those ships. The key to this is induction energy fields are all based on the weight of the metal and the magnetic properties of the metal. That's it. You can't throw anything else into this equation. So you have a certain temperature gauge that you acquire with each individual metal. All metals are different. Our earliest model was for a 120 megawatt plant. That 120 megawatt plant, we were going to build in Milton, Florida. To get up, we were looking at about 900 pounds mass. That's how much steam do I need to push through that turbine to make that turbine turn and produce the 120 megawatts it needs to produce. Well, basically you take the amount of metal that I have in this field, that I've shoved into this field in the surface area, and that tells you, for us, in inductor terms, that calculation came out to 6 to 8 megawatts. So for 6 to 8 megawatts, which we pull off the grid or from outside generation at the start, for that 6 to 8 megawatts, I can produce 900 pounds mass of steam at 700 degrees. That means I'm going to turn a 120 megawatt turbine. Regardless of what happens, that turbine has no choice to go. Because when you look at our system, once you leave this, we have a typical power plant all the way through. There's no difference. We use the same calculations that they use in every thermal plant. So as you go through, once I brought the heat into this, you start the plant up, those fields will engage, and those flow tubes will go up to about 5950 degrees. They'll stay that, the water will be pumped through, and the steam will get started. As soon as the plant's flowing, basically, this load, the load for the induction power supplies, becomes a parasitic load of the plant. which there are numerous parasitic loads on every plant. It just becomes one of, as long as we maintain the field is similar to gasoline. As long as that field's maintained, we'll maintain the heat and we'll keep making steam. Sorry, that's my voice.
Yeah, thank you, Brian. And just before we transition to Doug, who's gonna have a hard job of talking about how he's gonna be able to translate this on behalf of veteran-owned businesses into reality. We didn't tell you we're gonna give you the hard job. But I want you to talk about two other opportunities that I thought were just really interesting. That right here in our backyard, we have a decommissioned nuclear facility at San Onofre that everybody's aware of. And we gotta figure out how we're going to replace all of that baseload power. So why don't you talk about what you're doing within the nuclear arena?
We actually talked to San Onofre about it. San Onofre is a big case. You've got, the thing about nuclear power plants is they actually store their spent fuel. When you hear those stories about Yucca Mountain and they're gonna push all that fuel up there, it never happened. So San Onofre will have a 20 to 30 year storage period of their stuff. So it's a tough one to get into. The steam generators are the same, everything else is the same. We actually put in a solicitation, well, it was a call for development ideas. So we did it for a plant in Alabama called TVA Belafonte. Belafonte was started in 1974. So they've spent $4.5 billion on that plant and have never loaded the reactors. They went through, looked at our stuff and said, picked us and another company as potential developers. So we went through and basically said, we can do this, we can convert it. It's got two 1,250 megawatt units on the ground. It's got quite a lot of equipment, but it's a clean site. With San Onofre is doable, but the cost of nuclear, like nuclear production cost, maybe 2.5 cents per kilowatt. The cost of security on top of that, 2.5, is your cost for nuclear. So you may spend 2.5 cents per kilowatt production, but